Our final speaker is Rig Zekelberry, who's CEO of OriginOil, and I'd like to just emphasize two major accomplishments. Number one, he is a pioneer in developing oil out of algae, but more importantly, today is his 60th birthday, so congratulations and welcome.
Is he supposed to divulge that information?
Apparently. Yes, so the fact that he dragged me here from Los Angeles on my birthday means a lot. I'll be exacting payment. I'm going to dive right into it. All right, so I've put up a couple quotes up that actually came up today on my screen, which illustrates just how timely things are. I pulled a research brief by Raymond James on another company that really discusses a major factor for that company in the public markets. So the DOD's commitment to biofuels is actually becoming a factor in public companies. And then there was on Super Bowl Sunday, I'm sure you caught it on C-SPAN, that the Secretary discussed where they're going and talking about how they're really talking about, of course, going seriously into it. As you know, in December there was a first purchase of algae with a blend of algae, Tyson's waste cooking oil, and petroleum that was sold to the Department of Defense. And that made headlines. We know that Navy is on a very aggressive timetable. And of course that the Department of Defense is using Title III of the Defense Production Act. We all know this. Now, there's some uncertainty about this, so it helps that the aviation industry is sort of a second player and is facing tough, you call them sanctions practically, on travel into and from Europe by all world carriers. And that is Europe is being very tough with this and is likely to be a rapid driver. Okay, just took a quick excerpt here from Chris Tyndall's standard presentation. There's that 8 million barrel total, which is 50% of their demand in 2020. This is an incredibly ambitious goal, especially if you're going to try and make it from things like algae and waste. And I'll discuss why that's so. They're looking for integrated biorefineries, and that is a key point because what they're looking to do is sort of create a lily pad effect of biorefineries throughout the world in strategic locations. And these will be using a mix of sustainable feedstocks to essentially be coaling stations for the U.S. Navy. Agriculture has specified no impact on food production, and that will rule out, of course, the easy ones, ethanol, and of course the biodiesels from soybean and so forth. But fresh water is a sleeper. All land crops require fresh water, and fresh water is in some places the real key limiting factor to biofuels. Somebody said once that if you try to make biofuels, as much biofuels as there is petroleum in the world, you would use up all the fresh water. So that's not viable in the long term. If you do the logic on this, it really comes down to just two major feedstocks, and that is aquatic species and waste. There's a huge amount of waste in the world. It's not infinite, and we hope that aquatic species type production will overtake it. But the waste factor is, I think, a real key to scaling up rapidly. Basically, in December, we went into a CRADA with the Department of Energy cooperative research agreement to establish blending standards with these other feedstocks. In December, we went into a joint venture to start developing these biorefineries, and this venture has funding to pursue bankable feasibility studies for these lily pad biorefineries. And they're actually leveraging a service-disabled veteran-owned small business angle to make that work in the short term, because obviously it doesn't work once you get too big. We're actually working directly with the Defense Logistics Agency on this to ensure that the feasibility studies get done rapidly on selected sites throughout the world, that the offtake agreements quickly follow, and from the offtake agreements, of course, the refinery concerns can then issue offtake agreements to algae and other feedstock producers. This is on a very fast line. These things can get buried in minutia, but this is being done in a very high priority. And finally, we agreed with the Department of Energy at their Idaho National Lab to develop integrated production of fuels from algae. And what that means is that an algae producer could literally just make algae and then feed it into a 40-foot container, and out the other end would come crude or some kind of fraction of fuel, even possibly a direct transportation fuel distillate. And that is an incredibly enabling step, because if you know as an algae producer, and algae can be made anywhere there's CO2, if you know that you can create a commodity fuel on site, then it makes your business model very, very compelling if you can make all the parts work. So we are moving ahead with the advanced biofuels agenda. In other countries, carbon is the big driver. It's not here currently, but the military is helping in that regard. So is aviation with its problems with the EU mandates. Algae is emerging, and the reason is that even though we can't scale and we're relatively expensive, algae has a much higher energy content than various waste feedstocks, and it has a petrochemical profile. So it actually helps to format these other feedstocks in a blend, which makes it valuable and worth the trouble. And finally, our work with the DOE. We are in the harvest business. We're in the midstream. If you know anything about algae, you know that the biggest problem with algae is the Kool-Aid analogy. If you make Kool-Aid, how do you get the Kool-Aid back out again? Algae is in microscopic suspension in water, up to 5,000 to 1 dilution. How do you concentrate it? Currently, the industry does this with chemicals and lots of energy use. These are both unsustainable. We have a zero chemical, low energy, high flow solution. We're now working on this crude oil and distillates game. We are in the field. We are operating at our scale with a pilot partner. We're making money too. At the moment, we've offered a standardized modular product that any algae company can just pick up. It's a starter kit, gets them going. Our ultimate model, though, is to be a Dolby or a Qualcomm for the industry. And we think this is a unique model compared to a lot of the other people who intend to commercialize their technology in production. We think, and I learned this in the dot-com era, that you really don't want to compete with your natural customers and partners. So we intend to be a licensing entity versus trying to set up our own distribution and manufacturing infrastructure. Quickly, I'm just going to review what the flowchart looks like. You've got your classic algae growth system, be it bags, channels, photobioreactors, whatever. The inputs are, of course, water, CO2, and nitrates. And for the algae producer, these need to be waste inputs so they get paid for it. Also, there's a boost phase that allows the algae concentration to rise with additional carbon inputs like waste and so on into what we call the algae appliance, which is our little starter kit for algae producers. What comes out of that is a sludge of oily mud, and what it is cracked algae cells in a 10 to 20% solids. So it's still pumpable, but it's now ready for two ways to go. One is into what we call fractionation, which is how you get these pharmaceuticals and nutraceuticals, and that's a process that a partner provides. We don't do that ourselves. But we are going to integrate the post-processing for fuels. And the last bit of all this is our real-time control network. You see sensors throughout the system. We track the status of everything there and control it in real time. We actually update that database, or will update that database in real time from OriginOil, which hopefully will insulate us somewhat from people ripping us off. Quickly, why algae? You guys probably know all this, but algae, there's a reason for algae. It's molecularly the same thing as petroleum. It just doesn't have the bitumen, the tarry stuff that came out of fossilization. Not a food crop. Very happy to use any kind of water, including wastewater, salt water, brackish, fresh. It's a purifier. It actually uptakes all kinds of waste, including radioactive isotopes. Daily harvest, CO2, it's just wonderful. Now, why aren't we doing algae today? It is because of these technology barriers, not just in the harvesting area where we specialize, but in growth and downstream conversion. Advanced biofuels will overtake ethanol production by the second decade, and advanced biofuels, which is in great part algae, will become the dominant fuel by then. Okay, quickly, a couple slides on scaling up, or how it's really happening for us. Here is an artist rendering of what's being built in Australia around a power plant. These are extremely dirty brown coal power stations, and the people who furnished the coal to these power stations decided to try and mitigate it using algae for CO2 absorption. So what's the driver in Australia is a very, very high priority program to reduce their greenhouse gas overhead. They have the highest greenhouse gases per capita in the world. Here's sort of the scale-up that's been going on. We are now helping them build their 1 hectare display plant at Toorong Power Station. They have plans to go to 1,600 hectares per power station, which I believe would absorb something like 50% of the CO2. These are very, very CO2-dense power stations. Fortunately for us, we're not just doing it in Australia, we are doing it in North America. A big program has been launched in the Mexicali Valley, which is the delta of the Colorado, where there's some pretty good intersections of proximity to the U.S., Southern California. You know, it's an irony that California companies in algae do their research in California and go elsewhere to actually produce it. We have Aurora Algae, for example, in Western Australia. They're spending their second $100 million on production there as opposed to California. I think that's a real problem. Aquaviridis will be quickly scaling up actually to a very big footprint, 10 acres by the middle of this year, which is actually a lot for algae, and then multiples of that in the next couple of years. And finally, there's a big CO2 opportunity there with one of the largest geothermal sites in the world, which is creating all kinds of opportunities. Quickly to wrap it up, we're starting to scale up algae, and I've seen this happen before in .com, where all the technology factors come together and all the people who've been waiting for something to be real actually can step in. And I can tell you from the last 5 years in our business that there's intense demand from all over the world for people want to produce algae. They see where it can go, and they're just waiting for the technology. Various standards are being developed. We believe that that government must stay strongly behind this, or we're just not going to generate the critical mass. And of course, the DoD is a big player in this country. So we are really stepping up to rapid acceleration. I'm very excited about what's going on and pleased to be talking about it today.
Thank you for being here.
Yeah.
Thank you, Bill.
Thanks, Bill.